G'day guys, episode 9. Back again. This time nobody's damaged any of my work in the interim. Let's continue on. We're about to drill holes. We've marked out with our prick punch and our scribes and rules all our lines, and all our intersections are now stamped. So we have all our holes marked. We're ready to go over the pedestal drill and start drilling. Before we do that, just want to give you a quick demo here. I'm going to cheat. I've got a full set of drill bits here, which I will not give to you. The reason I don't give them to you is because I want you to practice your vernier skills. And by using them again and again and again, you'll remember how to use them. So I'm just going to check this one here. Now that's a 3 when I read the verniers. And I'll grab a 3 out of here. I know that's a 3 because it's a brand new box that I only just opened up 2 minutes ago. So I have 2 3s here. They're both made by Sutton, made in Australia, but we have what's their name? This one is their Viper series, and this one is their Inox series. The Inox has to do with a coating that they put over the outside of this. And it has, the coating is really hard, and it does help with the longevity of these drill bits. They will drill longer, but if you look at it under a microscope, it also has all these little tiny pitting holes in it as well. Those pitting holes will fill up with any soft metals. So if you're drilling brass or bronze or aluminium, this is no good because it clogs up the little pores on this coating. So don't use these for aluminium, brass or bronze or anything soft. These ones, perfectly fine, aluminium, nice hard coat. It has a hard coating, but they don't last as long as what this does, but they don't have any little pores. So this can be used on mild steel or aluminium or brass or anything else. These ones last longer, better for harder materials. If you're drilling stainless steel, definitely use this one, it'll last a heap longer. But if you're doing something soft, use one of these ones. We're doing mild steel, and I want this to last really well. So I've showed you it now. This is a brand new one too. No wear on this at all. The tips look nice and sharp. When I feel the edge there and the edge there, they feel sharp, they look sharp. And I'm going to use this one to do the majority of our pilot drilling. Again, a 3mm drill bit. We're going to call our pilot. You can use a 2.5 as a pilot, but a pilot is the initial drill that goes through. Generally, engineering terms, a 3mm is going to be your pilot drill. So let's go over to the pedestal drills and start drilling our holes. Everything except for this one is going to get a 3mm hole. Let's wander over. Set some stuff up on the right. What have I got to that? And I'm going to use the Inox one, not the Viper series one. I'll put that Viper series one back in its box. And then come over here. Do I need to clamp this down with a clamp? No, I don't, until I get to a drill bit with a diameter of 8mm or bigger. At the moment, you guys can you can see that thing flex when I push it. If this does tend to jam up for some reason, it's just going to break the drill bit. But once you get to about 8mm, it won't jam the drill bit. It'll start spinning the whole vise around. So that's why we have our vise over this side, because if it does spin around, all it's going to do is go bang, hit the mast and stop there. So let's leave that there. Now I can't just sit this in here any old way because it's a bit crooked. The drill bit will then go crooked too, and it will tend to wobble and go sideways and skew off into different directions. So we need it sitting flat. Grab one of our parallel bars from the previous year's class, sit them on. It's been put in the milling machine so it's nice and parallel, hence the name parallel bar. Same thickness all the way through here. Sit that on the bed of the vise, sit the drill gauge on top of it, put a finger load of pressure, doesn't need heaps, but a little bit of pressure on there, so when you're clamping it up, it doesn't want to raise up or anything. Now at that point, we should be able to drag our parallel bar out now. It's a bit tight. I'm just going to come out the other way nice and easy. Is it? I wouldn't say easy, but it's coming out. There we go. You'll see that's nice and parallel now. Let's start drilling some holes. The only one we aren't going to do is that 2.5 there, because this is a 3. So I'll come back and do that 2.5 in a second. Alright, now I'll talk about that in a second. Alright. I'll get that power. No power anywhere. That's no good. Sorry guys, let me go switch the power on. We had a blackout the other day. I may have switched the power off. There you go. I didn't know blackouts hit our safety or our emergency cutoff. So obviously we have go here, stop here. We also have power switches here. Now, there's also a mushroom button down at my feet. If I touch that, that's also going to turn the thing off. But over on the wall over here, there's another big red button on the wall. And there's another one way down at the sink. If those get pressed, then it kills everything in the workshop. So yeah, obviously that kills everything, and if we get a blackout, that also kills everything. Alright. I apologise about the poor lighting, but we will talk about that in upcoming OHS classes and how we can rectify that. Turn it on. We'll start drilling our pilot drills. Now just bring the drill bit down with the drill bit running, and you'll be able to see when it hits that little prick punch mark. Yep. Oh, I'm an idiot. I got sidetracked before I realised the power was off. I put it in here and I did it up hand tight. This is a keyed chuck, so we need a key to tighten it up. When we're tightening it up, tightening it is in the clockwise pattern, and we need to have the side of the key over here, or even better, up here, so when I'm tightening and putting pressure up, it's making the whole key go up, and therefore pushing it up makes the teeth mesh better, and therefore they won't slip. So, nice and tight. There we go, let's go again. Slide that vise around until it's in the right place. And away we go. Now, 1, 2, 3, 4, 5, 6, 7. Yeah, 7 seconds. If it takes longer than 10 seconds to drill a hole, then something's wrong with the drill bit. And it needs to be sharpened or it needs to be changed. At that point, come and see me. We will do some demos in class about how to sharpen drill bits. Now, there's something else I shouldn't be doing too, guys. Be careful. All these little bits of swarf, razor sharp. So just be careful. With those, I know I cleaned those out of the flute. I was just my ADHD doing something while I was talking. I couldn't just stand still. But be careful with that swarf. I won't do that again. I'll make sure I leave the swarf in there each time. If you feel so inclined to take it out, then go grab a scriber or something so you can actually dig it out. There we go. I'm not putting huge amount of pressure on this, guys. I'm not reefing down on the feed hand wheel. At the moment, I have two fingers pushing down on this. So don't worry about needing heaps of force. It's only a small drill bit. You'll also see how the swarf is coming off evenly. So when I drill, there's 2 bits of swarf coming off out of each flute. And those bits of swarf are coming out at the same length. So another one just came out the same length of that. Means the drill bit's been sharpened correctly. If I had just one piece of swarf coming out, then it'd be unbalanced. The drill bit won't have been sharpened the same on both sides. You'll notice I have my glasses on. Make sure your glasses are on too when you're at these machines. Anything can happen. A drill bit can snap and send off little shards of high-speed steel, or bits of swarf can flick off around it. The RPMs that this drill is turning at the moment is probably only about 200 RPMs, 200 revolutions per minute, which is relatively slow in relation to drill bits. And this drill bit that we're drilling with now could drill well over 2000 RPM quite easily, without it burning out or getting too hot. But having it spinning slower, it just means it's doing it safer. And it's less likely to wear my drill bit out, so they will last longer by going slower. Alright, so last one. Oh, sorry, no, I've got one more to do after this. I lied. Alright, the last one was the one that intersected the 121-degree angle, and it said it was a 3mm diameter, so we can also drill that one. There we go. Alright. One more drill bit. Let's go back to our 2.5. So with this, same again applies, but in the opposite direction. So you're loosening it now, so anti-clockwise, and again push up so that the teeth mesh. So let's, pushing up. There's our 3. Now let's do a quick assessment of this 3. You can see it still has a nice blue colour, but on the tips there, the cutting edges, Does look like it's lost a little bit of that blue, but both edges are still sharp. It was still cutting well within the 10-second time there. Yeah, that looks good though. So that was, what was that, 13 holes? 13 holes, and did it really quickly, and didn't wear the drill bit out. This drill bit would be good even through stainless steel a good few hundred times before it needed to sharpen. So, very good. Let's go back and do our 2.5. 2.5. Back into our keyed chuck. Tighten the chuck up by hand. Bring the chuck key over. Put it in. Make sure it's set up so that when you push the chuck key clockwise to tighten, that you're meshing those teeth some more. Alright, let's do our last hole. Now why didn't we just use a 2.5 for all our holes? Well, the reason is these 2.5s are 1/2 mil smaller than those 3s. 1/2 mil you wouldn't think make much difference, but take that out and push on that with my finger, you'll be able to see how far that flexes. So just being that little bit smaller makes it so much more flexible, and you've got to be a lot more accurate because they will tend to wobble around a little bit. So we don't use a 3 because of that extra wobble they have. Sorry, yeah, we use a 3, we don't use a 2.5 because of that extra wobble. Let's take that out. There's our 2.5. Let's go to our 3.5. Now we've done our 2.5. We've done our 3, so those two are finished now. Now we've got to finish all these ones off. Let's go to our 3.5 and drill that one. Again, tighten it up by hand. Chuck key, make sure the teeth are meshing more by having this being pushed up. And 3.5. Let's go through, make sure you've got the right one. Even quicker, because we're not drilling an initial hole, we're just drilling, we're just cleaning out the hole basically. And that took all of, I don't know, 2 seconds if that. Same again, oh sorry, opposite again, anti-clockwise to loosen it. Put that one back and I can grab a 4. Now my 4 is a whole millimetre bigger than the previous pilot drill. So I went 3, that one's done. 3.5, that one's done. Now I'm going to drill a 4, but when I drill a 4, I've increased a whole millimetre off my pilot hole. So I'm going to drill everything else as a 4. Let's do it this way so it makes more sense for you. There you go, arm, pushing up, meshing those teeth, turn it on, and away we go. Four. 4. 4. This is where if you're talking to people while you're trying to do this, you'll be distracted and you might put a 4 through the wrong hole. 4. 4. 4. 4. So by doing this and increasing our drill size every millimetre, we're not taking much metal out, but it's meaning that the drill, sorry, I don't want to take that out, I'm talking again. It's meaning that because there's such a small amount off there, that the drill bit will find a really central hole. Now,
It's 20.
fantastic, let's do one more. 4, I'll do the 4.5. Now this is where you've really got to pay attention, because once you start getting into the middle of your job, we've got to know where that 4.5 is. So the 4.5 is 1, 2, 3, 4 holes down. Fourth hole down, we'll put a 4.5. Right on. 1, 2, 3, 4 holes. That one there. Done. Turn it off. Take it out. Grab a 5 is the next one. Check your 5 back in. Tighten it this way so the teeth are meshing more. And now the 5 is 1, 2, 3, 4, 5 holes down. 5 holes down, and then I'm going to do the rest of these as 5s as well. One, 2, 3, 4, 5. And every one after that as well. Just remember, I don't need a clamp on at this point. When I do get to a diameter of 8, we'll start clamping the vise to the bed. You don't have to spin around and hit you in the face as it's moving around. Alright, let's take that out and have a little look at the squares. Alright, looks nice. Good. We've got 5s all the way through. We can start increasing our sizes now. We do have burrs sticking out of the back of these things. We'll talk about how we're going to fix that in our next video. Thanks guys, see you soon.